And our life would not be complete if we didn't go ahead and look at derivative of log functions. Remember, log functions and exponentials are opposites of each other, and therefore, even though you'll be dealing with mostly exponential functions, we cannot neglect that sometimes you may run across a log function or two. And so the derivative of ln of x is equal to 1 over x. All right. And this just goes from the rule that ln of x is equal to log base e of x. Now, if our base is different than base e of x, we end up with something different. So when we go ahead and take the derivative of a log where our base is some value a, some number besides e or 10 of x is equal to 1 divided by x times the ln of a. So 1 over the value x of our log times the ln of our base. Let's look at some examples here. So we have y is equal to log base 2 of x. And our derivative of this is going to be 1 over our value x times our ln of our base, which is 2. And sometimes, of course, we need to go ahead and use the chain rule. All right. So if we have an ln, we're going to consider our log function, our ln, to be our outside function. We're going to consider our f of x to be our inside function. And therefore, when we use the chain rule, we're going to have 1 over our value f of x times the derivative of f of x, which basically is going to give us the derivative of f of x over f of x itself. If we have a log of a base that's not e or 10 of f of x, then we're going to end up with 1 over the value of f of x times the ln of the base a times the derivative of f of x, which is going to give us our derivative of f of x divided by f of x ln of the base a. All right, let's go ahead and look some examples involving logs and the chain rule. Okay, so let's look at y is equal to ln of 8x. So now we have the ln of something that's not just only x. So what we want to go ahead with this, we know that we're going to consider our inside version to be 8x, and the derivative of 8x is just 8. We're going to go ahead and plug it into our formula for ln. So we have y is equal to the derivative of the top over the bottom. And that's actually, the 8's are going to cancel on this case, so this just gives us 1 over x. So having a constant in front of the x does not change our derivative at all in this case. If we have y is equal to ln of 8 minus 3x, now we have something that's not just a number in front of our ln. And so we're going to consider our inside function to be 8 minus 3x. And if we go ahead and take the derivative of that, our derivative of our inside function is going to be negative 3. And so therefore, we have 1 divided by our x value, 8 minus 3x, times the derivative of the inside of that function, which is just negative 3. And therefore, we get negative 3 divided by 8 minus 3x. Let's go ahead and look at example 3. Example 3 is a little long. So here we have a little more complicated example of ln over of the square root of x plus 5. Now it's easier to go ahead and deal with this as a fraction, so we're going to go ahead and change our square root to a 1/2 power. So now we have ln times x plus 5 to the 1/2 power. When we go ahead and deal with that, remember our log rules that we could go ahead and take this 1/2 power, move it in front of the ln. And so we have 1/2 ln to the x plus 5. And that comes from our log base a of x to the r. And we can go ahead and move that r to the front. And so this allows us to go ahead and do this. And so now we have f of x is equal to x plus 5 to the 1/2. And when we take the derivative, this 1/2 power is going to stay by itself. we have the ln of x plus 5, which is 1 over x plus 5, times the derivative of x plus 5, which is 1. And we're going to go ahead and multiply all that together, and we end up with 1 over 2x plus 5. All right, let's look at another example, number 4 here. So we have y is equal to log of 6x. That means our base is equal to 10. And because log of some number x without a base present means it's log base 10 of x. And again, we need to go ahead and look at the 6x. That's our f of x. If we take the derivative of that, it's just 6. So therefore, our log of 6x is equal to our derivative, which is 6, divided by, now this is a base 10, so we have 6x from our inside times ln of 10, because we can't leave the 10 out. We know that base is 10. The 6's can cancel out because that 6x is not inside the ln, which leaves us with 1 over x ln of 10. Let's look at one that is not base 10. So here we have y is equal to log base 2 of a function for x minus 3. So here we want to go ahead, and our 4x minus 3 is our f of x. Our derivative of that is 4. And when we go ahead and put that together, we have to follow our rules. So this 4x plus 3 is our x, comes in front. We have ln of the base, which is 2 in the denominator. And then we're going to multiply that by the derivative of the 4x minus 3, which is just 4. And that gives us 4 times 4x minus 3, that does have to stay in parentheses, times the ln of 2. Okay, so what if we have the derivatives of the natural log of the absolute value of x, or some log base a of the absolute value of x? It doesn't change anything at all. So if we have ln of the absolute value of x, if we take the derivative of it, it's exactly the same. It's 1 over x. If we take the derivative of log base a of the absolute value of x, we still end up with 1 over x ln of a. In other words, we don't need to change anything we're doing with these logs just because there's an absolute value involved for us. So if we have y is equal to the absolute value of 1 minus x, we still go ahead and look at our f of x as the inside 1 minus x. Take the derivative of that, which is just going to be negative 1. And our derivative is going to be negative 1 over my x, 1 minus x, in parentheses, ln of 10, because my log here, remember, is base 10. Right? If we go ahead and look at a word problem here really quick, if we have a total revenue received from the sale of X items, and they give us the revenue function is 30 ln of parentheses 2x plus 1, and the cost function is x divided by 2. I want to find the marginal revenue. And the marginal revenue is the derivative of our revenue function. So the derivative of our revenue function is 30 times the derivative of my inside portion is just 2 over my 2x plus 1, which is my f of x here. Going ahead and multiplying 30 times 2, I get 60, and so I end up with 60 divided by 2x plus 1. Next, I want to go ahead and find the profit function. Well, remember, my profit function is my revenue function minus cost. All right, so I have 30 ln of 2x plus 1 minus x divided by 2. In this one, it's kind of complicated to go ahead and try to combine those. It's probably not a good idea. This is sufficient for the profit function. You do not need to try to combine the ln and the minus x divided by 2. It's just going to get horribly messy. If we want to find the marginal profit when x is equal to 60, our marginal profit, again, is a derivative of our profit function. And our profit function is our 30 ln 2x plus 1 minus x divided by 2. And so when we go ahead and take the derivative of it, we end up with 60, because remember the derivative of 2x plus 1 is 2, over 2x plus 1. That came from our revenue function derivative right here. Minus 1 divided by 2, that comes from taking the derivative of x divided by 2. Remember, derivative of x is 1. That just leaves us with 1/2. Just go ahead and plug in 60 into that without simplifying. And we end up with about negative 0.004, or it's a 1,000th, or 10,000th, which is close to 0. So we can see it's approaching 0, and therefore our marginal profit is pretty negligible, which means we're not making a whole lot of money off of this particular product.